So yes, I have to provide an introduction to M2M and the Internet of Things, and I have 15 minutes to do it. Although this clock says 6 minutes, so I assume we're going to get reset. So what am I going to talk about? A broad structure. What's the point? What is the point of all of this? We all hear about M2M and the Internet of Things. I'm going to give a few examples of really what the impact of the Internet of Things and M2M can be. Some indication of how big it's going to be, some discussion of how the market works, and some discussion about the difference between M2M and the IoT, and also some likely touch on the keys of success. And that's a little like explaining the Industrial Revolution. So I'm going to take a fairly quick skim through it all. So what's the point? And here I'm just going to give you some use cases and some impacts of these use cases. First impact, this is a company called Sealed Air. You'll have seen the sealed air pockets that you get in deliveries from Amazon and companies like that, just the packaging. So the business model used to be that companies would buy these machines which make these air pockets, and now what this company's done, Sealed Air have done, is they've M2M connected this Sealed Air device, and they sell it as a service. The payment is per packet, and the machine is maintained, and what they've done is they've turned a capital expense into a service. More revenues, better quality of service, transformed that business model. Gerber Cutter. These guys make incredibly sophisticated cutting machines for cutting down pieces of wood that would then go on to make furniture, etc. So very precise cutting required, and what they found was that they were shipping these huge and expensive machines out, and they were being run, outwith of the confines of their warranties. So they were being overrun, in environments which were too hot, which were too humid. They weren't being serviced regularly enough, and then they were breaking down, and Gerber was having to go out there and fix them. And by M2M connecting these devices, what they can do is ensure that the devices are treated in compliance with the warranty, and then they don't break down. And again, they're saving a lot of cost. And providing a better service, and frankly, not leaking revenues or not leaking costs in terms of maintaining these devices, which they shouldn't have to be maintaining because they weren't treated appropriately. Irrigation in Spain. This was something which was done between ABB and Telefonica in Spain, and this is about controlling the irrigation of farmland in northern Spain, a very dry and arid region. And the net impact of connecting the watering or automating the watering solutions in this region was something like a 30% reduction in electricity costs in the farms that implemented this solution. They saved enough water, the equivalent to the use of a city of roughly 750,000 population. So huge impacts, and profits of the farms that implemented this solution went up about 25%. Huge impact from a simple little application. This is getting online, and these guys make clinical dishwashers, and the model used to be that the dishwashers were loaded, and a member of staff would watch the dishwasher complete the cycle, and they just sat there in case it didn't complete the cycle, because if it didn't complete the cycle, there was no equipment for operations and for surgical procedures the next day. 99% of the time it did complete, but the guy had to sit there and watch it anyway. Now he goes home, and if it doesn't complete, he comes back into the hospital to restart the process. Completely transformational. In terms of that little niche. There's another example here, waste bins that are only emptied when they're full. Equivalent solutions mentioned this morning in Santander. And of course, city transportation, etc. So what we've got here is a few examples of things which are niche and small, but within their little niche, these M2M connections and the applications wrapped around those connections really transform the way that business is done. So it's going to have a huge impact on the way we live and the way business is done. So now I have to come up with an obligatory numbers slide. And this is, these are M2M connections in Asia, just Asia, including China, I should add. And we define M2M as connections to remote sensing, monitoring, and actuating devices together with associated aggregation devices. I can go into that definition a little more, but I don't have time right now. Thing to note is that within our definition we have routers and Wi-Fi and network equipment, which is what accounts for the bulk of the connections in the early years. The growth is what most people would consider true M2M. It's the connectivity of new devices and new applications. It's going to be very well distributed. More so, there's going to be greater adoption in the most connected markets. The reason is that the more developed markets, the GDP per capita is higher. The spend on connected devices is greater, and people own more consumer electronics and so on, and also more likely to deploy intelligent building solutions. There is significant opportunity in markets which are less wealthy, but in terms of business applications and industrial applications, they tend to be driven by a business case, and in that case, in that situation, what you're looking at is the return on M2M connecting a device versus the cost of the manpower equivalent of sending a man to read the smart meter or to read the electricity meter, or a man to check on the status of a vending machine, etc. So, frankly, the less people are paid in a market, as a broad rule of thumb, the less easy it is to make an M2M business case cost in. So, vending in India, it might be cheaper to pay somebody to watch a group of vending machines all day rather than M2M connect them. That wouldn't be the case in Japan, for instance. So there's some quite different dynamics in the different markets and different factors behind the adoption. So, how does the market work? Well, here's a nice simple value chain, and you might consider that somebody, an M2M or IoT application starts off with an M2M device vendor, and then somebody provides the communication software. Somebody provides some horizontal service layers over that. There are people who systems integrators and application suppliers who eventually deliver that solution to a customer. You might think that's a broad. A broadly simple and sort of default value chain. Unfortunately, the reality is absolutely nothing like that. It's incredibly complicated, and this doesn't cover the full level of complexity. But the reality is that across the different applications and different solutions, there are different entities which are best placed to provide a solution to the end consumer or to the end customer. So just walking through a few of the participants on this slide. M2m Service Providers, the likes of an Aris or someone like that. They would pull together connectivity from multiple providers, present you across multiple technologies, and wrap that up as and assist with application development and provide those to an end user. Communication service providers. I mean, a great number of mobile operators are very actively trying to engage in this space and really trying to develop their own solutions and take those solutions direct to customers, and they're particularly well placed to do that in the case of small businesses which would buy productized solutions, and where telcos have fairly good relationships versus systems integrators, for instance, who may not have such good relationships with smaller business customers. There are M2M device vendors who are looking to add value to their solutions by augmenting with connectivity and turn capital purchases into services. There are all sorts of solution providers and systems integrators who are looking to provide bespoke solutions for larger corporates. The list goes on, and this is only a summary level. So it's very there is no set value chain. There is no defined value chain for M2M. Not only that, but for different applications in different situations, and that's a combination of what the application is and also what the end user is. It makes sense for different entities to potentially be the lead party in developing a solution and invoicing that to a customer and taking that and being responsible for the overall delivery to a customer. More than that, though, much of the logic behind who would lead in a particular value chain and pull together the other components and the other players that are needed to provide the solution is driven by the relationships of the customer. So it's a question of who has the best relationship with the customer. Is it a systems integrator? Is it a mobile operator? That will impact the purchasing decision of the customer and effectively what the value chain looks like in terms of who's providing what to who and who's servicing the end customer. And frankly, even worse than that, the situation at the moment is that everyone is playing this game much as 5-year-olds would play football. Everybody wants the customer. No one's saying, this is the piece I'm going to do, and leave other elements of value add to others who might be a better place to do it. Everybody wants the customer relationship. So the market for M2M and IoT is actually incredibly complicated, and it has not yet evolved to the point where it's settled down into defined roles and relationships within that market. Then we come to IoT. So M2M markets are changing to support an IoT world, and this is the difference between M2M and IoT, because in many ways that leaves behind a lot of the complexity that I've been talking about up until this point, and begins to assume that the devices are connected, and we're looking at an environment which enables applications to be written, assuming that devices are already connected and that devices coming into platforms to support analyses, etc. So just running through some of the key differences. M2M, point solutions, hundreds and thousands of remote assets. It's basically about standalone applications that are put together and connections that are deployed to support a specific business case, effectively, limited in terms of the number of assets. In the IoT world, solutions it's almost limitless. You would want to put together conceivably an IoT application which would draw from multiple standalone stovepipe M2M applications, and almost without limits to the volumes that you would need to process and deal with in an application. In traditional M2M markets, solutions, as I've mentioned, are structured as stovepipes. They're conceived as solutions for connecting a device for a reason, and there's a purpose at the point that device was connected, essentially in isolation, and with little, and currently, or up until this point at least, with little view of how that application would be stitched into a wider Internet of Things environment. So right now, for instance, a utility would be typically implementing a smart metering solution for the purposes of a smart metering solution and potentially to use that data within their organization. They probably wouldn't have spent much time thinking about how they might want to publish that information, that smart metered information, into an open environment so that somebody else can come along and write an application that combines that with the weather, position, and heating, ventilation, air conditioning control application, and to support that, there needs to be some level of structure of the information, and thinking of how information gets outside of that stovepipe M2M smart metering application and how it is shared. And the key, and the last element here is that application development in the M2M world is very much about considering each element of the stack, whereas in the IoT world, the point is to focus on applications. And this is the key. These last two elements, the key to the difference in M2M and the IoT. And this is where the leading companies in this space really are differentiating at the moment. So if I mention the likes of ThingWorx or Bosch, one of the things they're looking at doing is the semantic alignment of application information as it comes into their platforms, so that a third-party application developer can come in and pick up the data feeds from disparate applications and know what they mean, because there's some semantic commonality in terms of the information. So two applications might send a service engineer rather than the more detailed codes that are underlying that, which could be flag red or flag 8, and to understand without that semantic alignment, the application developer actually has to unpick what the meanings of the different flags and the different applications are, and that really is no good for supporting an IoT world. In summary, keys to success, there really are about three things to machine at this very high level, and this is a very quick skim through the market. Reducing cost. reducing cost in processes, increasing efficiency, and there's a lot of things going on in that space which help further reduce the cost of solutions. Reducing the complexity. Many companies are coming in with sort of one-stop platforms and solutions, and these are likely to be successful in the market. But most of all, to be successful in M2M, you need to consider solving a problem. What's the point of deploying the M2M connectivity? M2M and IoT is not a panacea for absolutely everything. Technology it's a tool and an enabler for something that you want to achieve rather than an end in itself. But lastly, I just finish off with one comment, which is that the implementation of M2M and IoT solutions it's not a matter of if, it's a matter of when. Right now, with regards to the M2M and IoT, we're in a situation analogous to the 1970s and 80s, and companies considering computer systems and mainframes. They will end up adopting those solutions. It's not a matter of when companies are going to, or when society is going to adopt these M2M and IoT solutions. It's a matter of when they do it. Thank you.